Section 11.2, Introduction to Equations. An equation expresses the equality of two mathematical expressions. Remember that an equation has a left side and a right side and an equal sign in the middle. Think of the equal sign as a balance. A solution of an equation is a number that, when substituted for the variable, results in a true equation. In other words, the left side equals the right side. For example, 4 is the solution of x plus 3 equals 7. If we were to substitute 4 in for x, the variable, we'd get 4 plus 3, which is 7. So 7 equals 7. Let's try the following problem. Is -2 a solution of the equation -2x plus 1 equals 2x plus 9? Let's determine yes or no by plugging in -2 anywhere we see the variable x. So we have -2 times -2 plus 1, and we have 2 times -2 plus 9. And again, my suggestion is anytime you substitute a number in for a variable, you always put the number in parentheses. So now we have +4 plus 1 equals -4 plus 9. We end up with 5 equals 5. That is a true statement. Therefore, yes, it is a solution to the equation. Is 1/2 a solution of the equation 2x times the quantity x plus 2 equals 3x plus 1? Step 1 involves substituting 1/2 in for any x you see in the equation. So we have 2 times 1/2 times the quantity 1/2 plus 2 equals 3 times 1/2 plus 1. Take your time, especially because we're working with a fraction. Do one step at a time. Taking a look at the left-hand side, we have 2 times 1/2, or 2 over 1 times 1 over 2. That gives us 2 over 2, or 1. So on the left-hand side, we have 1 times 2.5. That involves simply adding 2 plus 1/2. On the right-hand side, we have 3 times 1/2, or 3 over 1 times 1 over 2. That gives us 3 over 2 plus 1. Now we will further simplify. We have 1 times 2.5, that's just 2.5. On the right hand side, we can convert 3/2 to 1.5 and get 1.5 plus 1. Our final answer is that the left side and the right side are both 2.5. So it's a true statement, therefore 1/2 is a solution to the equation. Is 5 a solution of the equation x minus 2 quantity squared equals x squared minus 4x plus 2? Start by plugging in 5 anywhere you see x. So we have 5 minus 2 quantity squared equals 5 squared minus 4 times 5 plus 2. On the left-hand side, using the order of operations, we would first simplify the parentheses, 5 minus 2. So we'd have 3 squared. On the right-hand side, we have 5 squared, which is 25, and we also have 4 times 5, which is 20. So at that point, we have 25 minus 20 plus 2. And then when we simplify, we end up with 9 on the left-hand side and 7 on the right-hand side. 9 is not equal to 7, therefore it's an untrue statement. So no, 5 is not a solution to the equation. To solve an equation for a variable, you want to isolate the variable. That basically means to get rid of everything that is on the same side of the equal sign as the variable itself. And you want to start with whatever is least directly connected to the variable. The first set of problems we'll solve involve adding a number to or subtracting a number from each side of the equation to isolate the variable. Let's solve the problems. X minus 7 equals -2, x plus 8 equals 5, 4 plus m equals -2, -2 plus y equals -5, 3 equals y minus 2, 7 equals y plus 8, 2 sevenths equals 5 sevenths plus t, and finally 1/5 equals z plus 4/5. For number 1, we have x minus 7 equals -2. To isolate the variable x, we have to get rid of the -7. To get rid of it, we have to add 7 to both sides of the equal sign. We have to do the opposite operation. The opposite operation of subtraction is addition. What happens to the -7 plus 7 is they cancel each other out. So we have x on the left-hand side equals -2 plus 7, which gives us 5. You can check your answer by plugging 5 in for x into the equation. We have 5 minus 7, which is negative 2, equals negative 2. Number 2, we have x plus 8 equals 5. To isolate x, we have to subtract 8 from both sides of the equal sign. We have x equals 5 minus 8, which is negative 3. For number 3, we have 4 plus m equals negative 2. To isolate m, we have to get rid of the 4. That 4 is technically positive, so to get rid of it, we have to subtract 4. Whatever we do to the left, we have to do to the right of the equal sign. We end up with m equals negative 6. Number 4, negative 2 plus y equals negative 5. Add 2 to both sides of the equation so the negative 2 and positive 2 cancel each other out. We end up with y equals negative 3. Number 5, 3 equals y minus 2. Add 2 to both sides of the equal sign and we end up with 5 equals y. Number 6, 7 equals y plus 8. Subtract 8 from both sides of the equal sign, we end up with negative 1 equals y. It does not matter which side the variable is on, the left or the right. Number 7, 2 sevenths equals 5 sevenths plus t. To isolate the t, subtract 5 sevenths from both sides of the equal sign. We get 2 sevenths minus 5 sevenths, that gives us negative 3 sevenths equals t. Finally, number 8, we have 1/5 equals z plus 4/5. To isolate the z, subtract 4/5 from both sides of the equal sign. We end up with 1/5 minus 4/5, which is negative 3/5 equals z. The next set of problems we're going to solve involve multiplying or dividing both sides of the equation by a number to isolate x. Number 1, 2/3 x equals 8. Number 2, negative 4x equals 24. Number 3, negative 2x equals 6. Number 4, 4z equals negative 20. Number 5, negative 9 equals 3/4 y. And number 6, 8 equals 2/5 n. Number 1, 2/3 x equals 8. 2/3 is attached to x through multiplication. So to get rid of the 2/3, we have to do the opposite operation. The opposite operation of multiplication is division. So what we're going to do is divide both sides of the equation by 2/3. The 2/3 over 2/3 cancels out or just gives you 1. So at this point we have x equals 8 over 2/3, and what you can do from here is write it out horizontally as a division. So x equals 8 divided by 2/3. Now, remember when we have division with fractions, we change it into a multiplication problem by taking the reciprocal of the fraction after the sign. So now we have x equals 8 times 3/2. I have stars around this part of the equation, or this part of the process, because we can skip the first few steps by instead multiplying by the reciprocal, 3/2. We'll do that in the next few problems. So now we have x equals 8 times 3/2, which is really 8 over 1 times 3 over 2. We end up with 24 over 2, which is 12. Number 2, negative 4x equals 24. Negative 4 is attached to x through multiplication. To get rid of it, you have to divide by negative 4, so that you end up with positive 1x. Divide the other side also by negative 4 to get negative 6. Our final answer is negative 6. You could check your answer by plugging it in, and you would get negative 4 times negative 6 equals positive 24, which is equal to 24. Number 3, negative 2x equals 6. Again, negative 2 is attached to x through multiplication, so we have to get rid of it by dividing. Divide both sides of the equation by negative 2, and we end up with x equals negative 3. Number 4, 4z equals negative 20. To get the z by itself, divide both sides by 4, so we end up with z equals negative 5. Number 5, negative 9 equals 3/4 y. In one step, we can get the y by itself by multiplying both sides of the equation by the reciprocal of 3/4. The reciprocal of 3/4 is 4/3. What happens when you multiply by the reciprocal is you end up with 12 over 12y. 12 over 12 is simply 1y or y. So at this point we have 4/3 times negative 9 equals y, or negative 36 over 3 equals y. That reduces to negative 12. Our final answer is y equals negative 12. Number 6, 8 equals 2/5 n. Again, we can multiply both sides of the equation by the reciprocal of 2/5 so that we get the n by itself. So we're going to multiply 2/5 by 5/2 on both sides of the equal sign. We end up with 40 over 2 equals, that would technically be 10 over 10n, or just 1n, or just n. 40 over 2 reduces to 20. Our final answer is n equals 20. Our final two equations for this section are to solve number 1, 6z minus 8z equals negative 5, and number 2, 2/3 t minus 1/3 t equals negative 2. These problems are slightly different than the other problems we did in this section because they are two-step problems. The first step for these problems involves combining like terms. The second step is to solve for the variable. 6z minus 8z equals negative 5. Step 1 is to combine the like terms. We have 6z minus 8z on the left-hand side of the equal sign. That gives us negative 2z. Now we have negative 2z equals negative 5. The second step is to get the z by itself by dividing both sides of the equal sign by negative 2. Now we have z equals negative 5 over negative 2, or positive 5/2. That's our final answer. And finally, number 2, 2/3 t minus 1/3 t equals negative 2. Step 1 involves combining the like terms, in this case on the left-hand side of the equal sign. 2/3 minus 1/3 gives us 1/3. So we have 1/3 t equals negative 2. The next step and the final step is to get the t by itself. Now, because we have a fraction attached to t, we are going to multiply both sides of the equal sign by the reciprocal. So multiply both sides of the equal sign by 3 over 1. So on the left side, we end up with 1, or 3 over 3t. So t equals 2 times 3, negative 2 times 3 over 1, which is negative 6. Our final answer is t equals negative 6.